Our example shows the logic of simulating the movement of a robot arm that moves a cube from one base to another. The robot's arm is made up of the bodies 1, 2, 3, and 4. Solid 5 is the base on which cube body number 7 is positioned. Solid 6 is the lateral base where the cube will be transported. Remember that in a simple simulation, the variable that controls the movement can be used to control each simulation cycle. In our example, the simulation undergoes horizontal and vertical translation and rotation movements also in 2 directions and with clash tests. Therefore, we must use an extra variable specifically to count the cycles. A variable S counts the movement cycles. Each cycle represents a complete command list processing. The cycle variable S starts with 0 and goes up to 500. Its final value, in this case 500, must be sufficient to complete all movement simulation conditions. To finish the movement, a command called break ends the movement simulation. That is, when the last movement condition is reached, the simulation is aborted. Let's set the following options in the simulation box. Process parameterization. During the movement, all logical conditions must be tested, as well as retrieving information from the model, such as associating a variable with a distance, points, etc. Set following options: show variables list, show user messages, clash test. Perform a crash test with the clash test command. To facilitate understanding the full simulation process, it was divided into 4 parts, each one with a solid face model file named P0 to P3. And show the simulation. That is the full simulation process. Let's modify one dimension to check if the logic is correct. Create a 3D line dimension for the height of base 2. Edit the lateral base extrude feature. Enter a variable h for the extrusion distance. Although it is not necessary for parameterization, visualize this dimension with the variable h. Test the simulation. Note that the collision of the cube with base 2 determines the release of the cube regardless of the height defined by the variable h. We are going to explain the P0 model process. In addition to the S variable, which counts the number of cycles of list command processing, and the M variable, the following variables are created. dy for vertical arm translation, dxg for claws horizontally translation, C1, collision control flag between the claw and the cube. In this model, the simulation has following conditions. The variable m defines various simulation conditions. If m equals 1, do the vertical translation of the arm. If m equals 2, do the horizontal translation of the claws towards the cube. If m equals 2 and the C1 variable collision flag is 1, abort the movement, display the end process message and modify the variable m to 3. Let's define a sketch on the cube face and create a vertical dimension from the center of one of the claws to the center of the cube. The value of the vertical dimension is 57. This is the distance to translate the arm till the cube when the variable m is equal to 1. Let's create the logical conditions to control the movement. Defining the first logical condition, when s is equal to 1, change m to 1. Show the message, begin simulation. If m equals 1, there will be a vertical translation of the arm. If m equals 1, increment the dy value. Set the variable dy equal to dy plus 1. Remember, expressions must be defined in parentheses. Use the dy variable in the move function with bodies 2, 3, and 4. Set y in a negative direction. The move function produces the movements necessary for the simulation. The robot arm goes down until it reaches the value of 57. When this value is reached, the variable condition m is changed to 2. If m equals 2, make dxg equal to dxg plus 0.5. Note that the subtraction value is 0.5 and not 1. This allows finer control of the movement. The two claws move horizontally and in reverse directions. Moves claw 4, variable dxg plus x direction. Moves claw 3, variable dxg in minus x direction. Set the Clash View option to visualize the collision of solid edge lines when a collision occurs. Create the clash test command between claw 3 and cube 7. The collision test function checks whether bodies collide. A control variable or flag C1 is set to receive a value equal to 1 in the event of a collision. If there is a collision, modify m to 3. Testing the movement of P0. The logic simulation of models P1, P2, and P3 was created in the same way as described in this video of model P0. Open these models and check how the simulation logic was created.